In this video, we're going to have a look at how to manipulate arrays by changing individual elements, or groups of elements. I'll create an array of pseudo-random integers to use for the demonstrations. Let's call it M. The array M is going to contain integers from 0 to 20 with 4 rows and 6 columns. Let's open the array in the variable editor so you can see what's happening as we go through the following steps. We'll start by changing some of the individual elements from the array. Let's take this number 13 in the first row and second column, and let's change that number to be a -2. We define the location in array M, so that's the first row and second column, and we make that value equal to -2. Watch what happens to the highlighted element when I press enter. We can use multiple indexing to change several elements at once. For instance, the expression shown here will take the two elements highlighted and make them equal to 1 and 3. If I try to pick two slots in array M and make them equal to 3 values, then we'll get an error, because there are too many values to fit in the given slots in the array. Similarly, if we try to take 3 values and replace them with 2, we'll get the same error. This time there are not enough values to fit in the slots in the array. By the same rationale, if we take 2 slots in the array and try to make them equal to a single value, then we should expect to get an error because there are not enough values to put in the array. In fact, Matlab does allow you to abuse the notation this way. Both of the elements are going to be replaced with the value -2. Now let's have a look at how we can use the same techniques to swap items in an array. Suppose that we want to swap the highlighted elements in array M. We could do this by introducing a temporary variable, which I'll call temp. We want the third column, and we want the second and fourth rows. What we can do, however, is access the elements in a different order. We'll get the one from the fourth row first, and the second row second. This gives the two elements with the order reversed. Now let's put them back into the array in the appropriate positions. We want to make the second and fourth rows in the third column equal to the variable temp. Watch what happens when I press enter. In fact, this could all be done in a single step, without the need for a temporary variable. I'll swap the elements back to demonstrate. We can do the same thing with whole rows or whole columns. For example, suppose that I want to swap the last 2 rows of array M. I use a colon here to select all of the columns, and I enter the row numbers here. The last row can be referenced using end. Having selected these 2 rows, I'll put them back into the array with the order of the rows reversed. Notice that the row and column indices are being given as vectors, and so it doesn't matter if I use spaces or commas or semicolons to separate the elements. When I press enter, the last two rows will be swapped. As another example, I'll swap the second and third columns. We want all rows and the second and third columns, and we swap the order of the two columns. Now let's suppose that we want to add two more columns to array M. First, we create the two columns that we want to add. I'm going to create an array of random integers from 0 to 20. We need the same number of rows as there are in array M, and we want to make two columns. Notice that I'm overwriting our previous result for the variable temp here. Joining two arrays together is called concatenation. We enclose the arrays that we want to join in square brackets, like this. We're going to put M on the beginning, and we're going to put the new columns on the end. I've used a space to separate them here because we're appending the elements on the end of the rows. I'm going to overwrite array M with this new result. I could also add the columns on the beginning. For completeness, I'll give an example of adding rows as well. I'll add 3 rows, and to get the appropriate number of columns, I'll use the size command again to reference array M. Notice that by using the size command, I never have to count how many rows or columns are in array M. If I was writing a script, this would be highly recommended, because it means that if you later go back and change preceding lines in the code, you wouldn't have to change this part. I'll add the rows on the end here. So we concatenate in the vertical direction, that means we use the semicolon. Inserting rows or columns in between other rows or columns is not so easy, but it's rarely required. In fact, changing the size of an array is not usually recommended, because it requires a very inefficient use of computer memory. If you know from the beginning that you'll need to add rows or columns, then the trick is to start with an array full of junk elements that you can later overwrite as necessary. Normally, we might start with an array full of zeros, because we can easily create one in Matlab by using the zeros command. For example, if I want an array with 4 rows and 5 columns of zeros, I can just type 0s, 4, 5. Let's overwrite array M with this new array full of zeros. Now I can go through array M, changing rows or changing columns or individual elements at will until I've filled up the array with all of the elements that I want in the final outcome. I'll provide a neat example where I go through filling up one column at a time. I'll fill the first column with 1s, the second column with 2s, and so on. So I'm going to do this for every column. And in each step, I'll take the ith column from M, and I'll replace it with a constant vector. We can get a vector of all ones by using the ones command. We want it to have one column and the same number of rows as there are in array M. By multiplying this vector by the column number, I can get 1s for the first column, 2s for the second column, and so on. I mustn't forget to close the loop using an end. When I press enter, everything will happen in a flash. But what happened here is that in the first step, the first column was replaced by 1s, in the second step, the second column was replaced by 2s, and so on.